Hi everyone, it's Nate. Welcome back. So in this video we're going to talk about what happens when we have not only two charges affecting one another, but when we want to consider any number of charges, all the way to 1 charge, 2, 3, 4, etc., all the way to n charges. So we want to consider this charge here. This charge, we're just going to let it be little q, just for the sake of differentiating it from the others. If we want to, let's just list some points just somewhere. Let's consider these other dots as different charges that are placed some distance from this little charge q. We want to know the combined force they're all putting on q. Just like in introductory physics, your forces are going to sum up. So you can just find the force this guy on q, and this guy on q, and this guy on q, and add them together to get your net total force. For example, let me do this off to the side. Alright, let's say these positive charges out here. This is a negative charge here. If I'm concerned with how these two charges are going to affect this guy, not necessarily how this affects this, but just how this guy is affected by these two. Assuming that these guys are both the same value, it's going to give an equal and opposite thing going on here, in which case you're going to have Q1, Q2, Q3, sorry I keep getting ahead of myself, to be explicit, Q1, Q2, Q3. The force Q1 on 2, and the force 3 on 2. They'll be in the opposite but same magnitude, assuming these guys are Q1 equals Q3, and Q2 won't go anywhere. It's being pulled at the same amount, but in the opposite direction, so the net force is going to be 0. Okay, so let's go back to considering this guy. Let me go ahead and name all the little points real quick. Now, just as before, we're going to pick some origin. Just let's say there does exist, in fact, an origin. Let's just place them out here. Now, from this origin, I'm going to draw a point, just some lines that lead from the origin to all the different charges that we have going on here. Anyway, okay, there's some pretty lines. All these are just lines connecting the origin to all these different charges. Simple enough. Now, same way in the last example, or last derivation thing, let this guy be our little r1, this guy to be our little r2, little r3. From the origin to the charge we're concerned with, q, we're not necessarily going to put a subscript onto it, we're just going to say r. Okay. Now consider this guy again. I know I keep bringing him up, but vector, vector, difference of the vector, leading to the point of interest. Gonna do the same thing. I'm gonna call this big R1. I'll assign values, what he means in a minute. I just want to draw the pictures real quick. Okay. Now, we want to know what his actual value is. I'm actually going to write it out here to the side. And it's going to follow suit for all the other charges, which your R2, gotta be careful not making my R's look like gammas. Jeez. So, it's what all of our big R vectors in this expression represent. Now, the same way I said at the beginning that our forces are going to be additive, we can go ahead and consider the force this guy has on him, the force Q2 has on Q, and separately consider Q3 on Q. At the end, add them all up. We want to consider our first force. It's going to be Q, Q1, Sorry, I just wrote it down real quick. So same way we derived in our previous... So yeah, this isn't the one we actually used, this is my separate one. But same way we derived this guy in the previous video, we're just applying him. So we can do the exact same for F2 and F3. Q, Q2, our arrow 2, 4 pi epsilon naught, R2 cubed. Hope I'm writing these big enough. If anyone's having issues, if I'm writing too small, I guess I could say, let me know, seriously. No, like, buy bigger Sharpies, I guess. Because these are pretty fine tipped. Okay, also didn't clutter up too much, I hope. So this is our force 1, 2, 3, that force 1, force 2, and our force 3. And we just add them up. And I'm trying to show you, like, grind through this and show you something more important that's happening. But I gotta continue, show you. So our net force on the system, stop turning sideways, Nate, is our F1 plus our F2 plus our F3. Okay, so I actually just skipped the writing and it's okay. Now we have this guy. We can pull out our like terms that is shared by all three of these quantities, which is the only thing that doesn't change is, of course, our 4 pi epsilon naught. It's a constant, it's in all of them. Also notice our little q is in every expression. All of these are affecting q. Of course, it's going to be in every expression. I can pull those out. I'll show you what's bigger picture, what's going on here. So q over 4 pi epsilon naught, in which case we're going to be left with on the inside q1 r1 q2 r2 over r2 cubed plus q3 r3 r3 cubed. So that's what we're left with on the inside. Now, if I wanted to condense this down, I could rewrite this as a summation. Notice all these expressions in here, R1, 2, 3, I can condense that down to a summation. Things start getting a little bit prettier. Actually, I have gotten in way too much trouble for not using equal signs properly for the sake of being explicit. There we go. So, 4 pi epsilon naught, all that underneath q. Stop turning the paper sideways, Nate. We're going to sum from 1 to 3. In this case, we do have 3 expressions of qi, ri over ri cubed. Alright, let me pull this back out for you real quick. Now, the same way we did use this guy to show the distance r1 to r2, you can also show it as this. In case r1, r2 is actually can also be shown as the distance from their origin, there, whichever point you want to consider as your origin starting point, little r2 minus little r1. 4 pi epsilon naught q I equals 1, in this case 3 qi little r, which is going to be constant. This guy is not changing at all. Nate, stop turning thing. And this becomes our actual expression. In which case, if we were wanting to consider, this is only considering 3 charges. But notice the only thing restricting me to 3 is what I'm putting my upper limit on my summation. So, if I was wanting to consider any n number of charges in a system, how they're affecting one particular Q, I could just rewrite this. It's Q over 4 pi epsilon naught. I is equal to 1 to any n number of charges you want to consider. Qi R Ri Alright. Nate, turning thing. So, this is our final expression before we get into any kind of example. So, as for this video, that's it. The video is probably pretty long. Sorry about that. But anyway, here's this derivation through all of this. Hope it made it, if you weren't following, made it clear. Thanks for watching. Let me know what you think, and I'll see you in the next video.